We're going to talk about card hands and decks of cards a little bit later after we've gotten everybody up to speed on just what's in a deck and some of the terminology. So we're going to skip number 4 and move on to number 5. So you should have looked at that, and you should have some attempt at solving this before you see what we've done here. Okay, well, again, we have 5 tosses of a fair coin, and we're looking for the probability of getting 3 heads. So we're looking for the probability of 3 heads on 5 flips. Now there's the answer, but let's see how we get to it. Okay, well, first of all, let's visualize the sample space for 5 tosses of a fair coin. Now, I haven't listed the whole sample space, but I've listed the sample space for 3 tosses. We have on the first toss, we can get heads or tails. And on the second toss, then we can get heads or tails. So we're going to append a head or tail to each of the results for the first toss. And then for the third toss, same thing, a head or tail appended to each of the possible results. So in the first 3 tosses, we have heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. We would go on for 2 more steps. It should be clear that at every step we're doubling the number of possible outcomes. We have 2 possible outcomes here. On each of those we append 2 outcomes for the second flip, giving us 2 times 2 is 4. And then for each of those 4 we append 2 more, that gives us 8. If we go 2 more steps we'll get 16 and then 32. We could also list the sample space. Now there'd be 32 of them, and I didn't list the entire sample space. I just began a listing. I listed heads, 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 tails, etc. And if you keep these alphabetical and don't miss any, you'll end up with 32 outcomes. Some of those outcomes will have exactly 3 heads. Now, neither of the ones that I listed here do, but pretty soon we would get to some outcomes that have exactly 3 heads. We could count those and find that there, well, we would find that there are 10, but we're going to not do that by actually listing the sample space or the tree. We're going to do that using the reasoning from the counting chapter. Now, first of all, there are 2 times 2 times 2 times 2 times 2 equals 32 possibilities. We can reason that out by the fundamental counting principle. There are 2 possibilities on each flip, 5 flips. That gives you 2 times 2 times 2 times 2 times 2 equals 32 possibilities. Now, how many of those possibilities have 3 heads? The way we've visualized this before, the way I've chosen to represent it, is you have 5 slots, and each of these slots can be filled with a head or a tail. So that we're going to, if we fill them all with heads, we get this outcome. If we fill them, the first 4 with heads and then 1 with tails, we get this outcome. Now the question is, how many ways are there to fill exactly 3 of those slots with a head? Well, we're going to pick the first slot. Which one of these slots do you want to fill with the first head? Could be any one of the 5. So there are 5 choices for which of the slots is the first to get the head. And having chosen that, there are 4 choices for which slot gets the second head. And then 3 choices for the third slot to get a head. Now, that would be ordered choices, because if I put a head here, then here, then here, that would be counted among these 5 times 4 times 3 choices. But if I put a head here, then here, then here, in a different order, I'd still have heads in the same positions. They would just have been selected in a different order. And all we're looking at is how many heads, how many tails, and which position. And among the 5, we get the heads. So that if heads are in these 3 slots, there are 3 factorial or 6 ways to put them in those slots in different orders. we'd still get heads, tails, heads, heads, tails if we had heads in these three slots here. This one, and this one. Okay, well, so that reasoning, which should be very familiar to us from the preceding chapter, says that there are 5 times 4 times 3 ways to choose these in order, divided by the 3 factorial ways to order these choices, and that comes out, and you can calculate that easily, to be 10 ways. Another way to reason it out is we just think of choosing 3 of these slots out of the 5 to put heads in, and the order in which we choose them doesn't matter, so there are C of 5, 3 ways. And remember that C of 5, 3 is the way we type out the combination, and your book will represent that as 5C3 or C of 5, 3. Okay, so there are 10 ways to get exactly 3 heads. There are 32 possibilities, so the probability is going to be 10 divided by 32. The number of ways you can get them, number of ways to get 3 heads. That's 10 over the total number of possibilities. And I'll say total number of possible outcomes just to be a little more precise.